All right, so starting here. So you should make sure you get this done, submit it through Canvas by midnight. Remember how we went over how to submit using a device, or if you need somebody to take a picture for you before you let me know, and I'll take the picture for you. Whatever you need to do, make sure you do it. All right. So parent function attributes are what we call constant linear quadratic function. Do all four of those functions sound familiar? You see, kind of opening that Algebra 1 file cabinet again. So we're going to first start with our constant function. So with the constant function, what that looks like is you have f of x equals c. Oh, it's not being nice to me. That's a horrible looking c. Let's try that again. F of x equals c. And c can be any number. Okay? C is, I don't know why C isn't liking it. C is any number. Oh my Jesus. I'm gonna have to pause on that. I'm just gonna write directly. C is any number. Okay? So when we look at this function, right now, this specific line goes through 2, if we count just the units, right? 1, 2. So we would say this is y equals 2. Easy enough? So then just looking at this function and analyzing it, the domain, so from left to right, what is this function doing? It's continuous, right? It goes forever to the left and to the right. So if I'm going forever to the left and to the right, my domain is negative infinity to positive infinity, right? Or if I was to write it in set notation, x such that, and I think last week I forgot to mention that there's a symbol in between the r, this is all real numbers. It looks like this. X exists in the real numbers. So that little e means exist, it's part of. So this is our interval notation, this is our set notation. Comfortable? Okay, with your range is just whatever y is. So the range here is what? 2. The one for this one is y equals 2, so we write y such that y equals 2. But is there going to be 2 for every single problem? No, it depends on what it is. So in this case, our c equals 2, and that's why we put a 2 there. Okay, there isn't an x-intercept, so NA unless y equals 0. So there's only an x-intercept if y equals 0. Okay, for the y-intercept, your y-intercept is going to be wherever you cross that y-axis, right? It's going to be whatever y equals 2. So it would be 0, comma, your c value. So in the case of this problem, it would be 0, comma, 2. Is this okay? Huh? Oh no. Asymptotes. So asymptotes, remember those are our imaginary boundary lines. Is there any imaginary boundary line that stops me from making my shape? No, so it's NA. Okay, maximum. So the maximum of this, there isn't one. And there isn't a minimum. And which type of symmetry do I have? Rotational, reflectional, or none? Reflectional. And that's because I'm divided by the y-axis, right? The y-axis evenly divides me into 2 parts. Now, I do not have an inverse function, but I have an inverse relation. So we're going to cross out the word function and write relation. Okay? My inverse relation is x equals a number. And I'm just going to put d for some number. My inverse relation would be x equals some number. That's my perpendicular line, right? So the opposite of being horizontal is to be perpendicular. Does that make sense? Any questions about a constant? We're good? No one? Okay. We're going to look at our classic linear. So this is our linear equation. And so when we write linear, we write it as y equals x. Now, as we have progressed in Algebra 1, when we write it in slope-intercept form, that's y equals mx plus b. Agreed? Does that form look familiar? So if you write it in y equals mx plus b, remember your m is your what? Slope. M equals my slope, and b equals my y-intercept. Squeeze it in there. Okay? So looking at this, the parent function goes through the origin. So for the parent function, b equals 0, and my slope, my rise over run, equals 1. Do you see that? Okay? So the domain of this function, is it going on forever? Yeah, right? So I'm going to just write from negative infinity to positive infinity. Is the range going on forever? Yeah. Negative infinity to positive infinity. X-intercept. There will be the x-intercept of the parent function is smack dab at the origin. And so is the y-intercept. Do you guys understand where these attributes are coming from? Yeah? Okay? Asymptote. Is there an imaginary boundary line preventing me from going on forever? No. So it's an NA. My maximum. So my maximum does not exist because I go on forever. My minimum does not exist because I go on forever. What type of symmetry is this? What'd you say? It's rotational. If you take your paper and turn it upside down right now, would it still look like an increasing line? It does. Because the deal for rotation, it goes through the origin. Does it go through the origin? Yes. And if I was to reflect it horizontally and reflect it vertically, which just means make a 180-degree turn, it would still be the same. Okay? How do we feel so far? Doable? And its inverse function does not exist. Because it is its own inverse. And that's because your y equals your x along every point. So, and technically, so I guess technically right. The inverse would be x. It would still be itself. Because if you look at the graph, your y's and x's are already equal to each other. See it? All right. Questions, comments, or concerns about constant or linear? Cool. So we're going to flip over quadratic. So quadratic functions. Quadratic is y equals x squared. The other way that we learn quadratic is the quadratic equation. The standard form, y equals ax squared plus bx plus c. Okay. If you look at our quadratic parent function, there are some key points. We have our origin. We have our parent point. We have 1, 1, 2, 4. We have negative 2, 4. Negative 1, 1. And we have 3, negative 3, 9, and positive 3, 9. Okay, so the arrows tells me that the domain is doing what? Can you see this? here we go. So our domain is still negative infinity to positive infinity. Our range this time, we have a low point, right? So our range isn't all real numbers. Our range starts at 0. So our range is y is greater than or equal to 0. Or if I write it in interval notation, it's from 0 to infinity. What is our x-intercept? 0, 0, and so is our y-intercept. If my x-intercept is at the origin, automatically my y-intercept is at the origin. Asymptotes still do not apply. The parent function does not have a maximum, but the parent function does have a minimum. Okay? It does have a minimum at x equals 0, or at the origin, 0, 0, right? That is at symbol. Type of symmetry, rotational, reflectional, or none? It is. You want to say the right thing, reflectional. Okay, how do we feel about quadratic? All right, its inverse function. Its inverse function is the square root function. Okay? Notice how I'm putting that -1 on the y? That lets me know that this is its inverse. Does that make sense? Questions about the quadratic? Good? Okay. All right, square root. So we have the square root function. The square root function is y equals the square root of x. If you look at our graph here, you'll see our key points are at 0, 0, 1, 1, and 4, 2. The domain. This time, there is a specific starting point, right? I do not go on forever to the left. I have a starting point. So where do I start? At 0. So my domain is from 0 to infinity, or I can write it as x is greater than or equal to 0. Agreed? My range also has that same starting point. So therefore my range is written the same. 0 to infinity, but instead of x, it's y is greater than or equal to 0. My x-intercept is at 0, 0, so my y-intercept is also at 0, 0. There is no imaginary boundary line affecting my life, so then therefore, in A, because I'm going forever and increasing, there is no maximum. My minimum value, my minimum is at x equals 0. And is there rotational, reflectional, or none? None. None. Okay? Its inverse function is the quadratic. The inverse equals x squared. Because the opposite of squaring something is to take the square root. The opposite of square rooting something is to square it. How do we feel? Good about the attributes? Pretty straightforward? Cool. All right, so we're going to go to practice. So this is our class practice, using our notes, talking about it, communicating with one another. If you're online, they're doing our discussion board format. So this is where we're doing it, and they would do it in a discussion board. So here we have a parent function when graphed has the following attributes. So we've got to decide which one is it describing. So it reflects across the x-axis. The domain is from negative infinity to infinity. The range is from 0 to infinity and has no asymptote. So out of our choices, which one would that apply to? Before we just learned, which one would it be? So is it constant? Is it square root? Is it square, the quadratic, or is it the linear? quadratic, good job. Okay, quadratic function. Oh, this is a typo. This should say y-axis. Alright, next. Stephen was asked to graph the linear parent function as part of a game in math class, and then to describe the function's graph. Which following could not be part of Stephen's description? Okay, so he's graphing the linear parent function. Is it the domain and range include all real numbers? Is that true or false? Is that a true statement for linear? It's true. All real numbers for domain and range. The maximum and minimum include all real numbers. It has no symmetry. And it has two asymptotes. It has what? There's no asymptotes in a linear function, right? I feel like this graph, when we're describing linear, it has symmetry. It has rotational symmetry. And it has no asymptotes. So I would say you could either tell me C or D. And the reason why it says the maximum minimum include all real numbers is because depending on what their interval is, it could be the max or the min. Like if I cut the graph, say, where's the max or min? Cut the graph, where's the max or min? So if you chose C or D, you would be correct. Which of the following can be used to represent the domain range of f of x equals c? So how would I represent the domain and range of f of x equals c? So 2 is saying that the range is y, and y is all real numbers, and y is greater than or equal to 0. Well, couldn't it be below the 0? So if you look right here at 3, you know how it says C to C? That means I'm saying like 1 to 1. Am I making any room for error for anything to be included? So it's like if on our example we had 2, right? Ours is y equals 2 in our notes. And so if I was to write its domain on an interval, it would be 2, 2. Because that's the only value that exists. Does that make sense? And so even though it's redundant and ridiculous to write, when you could just write y equals 2, this is the one that would be the right solution. Okay, so Samantha is giving us descriptions of a function, and she wants to tell her which one it is. It says the inverse, the domain is x is greater than or equal to 0. The range is y is greater than or equal to 0. Its inverse function is g of x equals x squared, and it has no asymptotes. What did she describe? Square root. Y equals the square root of x. So that's what we're trying to make sure you can do, is like without using, you're going to eventually get to the point where you can pull information from the notes just from your brain. Any questions, comments, or concerns? Okay. So here is our classwork for the rest of the period. You should have picked it up. It is, so the first part, you're going to match the functions with their name and equations. Second, you're going to do it by attributes. And then third, you're going to, number 9, you're going to just kind of write whether it's true or false. Okay? I'm going to challenge you to do it without your notes. So the challenge is to hide your notes for yourself. It's a challenge. And then go back and check yourself. Okay? All right.